manufacturing method in 1981. Then Chuck Hall came up with a new technology in 1984 called stereolithography, which is adding more layers on. But he wasn't actually coming up with anything from scratch. He was just adding to the technology that already was found by Hideo Komada. Then in Stanford University during 1990, there was the development of microcasting. And now, in our days, starting from the 2010s, 3D printing is widely used in manufacturing and producing new products.
The process is like taking each individual slice of bread and then gluing them together to make a whole bread. 3D printers just make 1,000 of tiny slices of the main part, and they just start building from bottom to top. Basically, the 3D printer gets situated into a specific coordinate of the set axis. It starts to print along this plane, and then when the shape is over, it starts building another set coordinate. All those slides lose each over because we have increased the temperature of the material in order to get a better ductility and also to be sticky. Inside the most common 3D printers that we use nowadays, we can find two types. The first one is the field deposition model, in which we use balls of yards of polymers and we just create by extrusion our piece. And we also got the 3D laser printers, in which they use 2D technology to print the shape, and then automatically they add another new part to create the 3D shape.
So, it's obvious that 3D printers will take a place in our lives. But what are the limits? Let me tell you the limits. NASA has sent 3D printers to space stations to make food. Everyone has dreamed of that. I'm gonna buy a 3D printer and I will make weapons. No, it's not working like that. You need really tough permissions for that. The general usage areas of 3D printers are simply medical, pharmaceutical, industry, maybe jewelry, armor, weapons, and also for architects and construction.